Insulin. Insulin forms usually the opposite of what glucagon is. It's formed also in the islet and specifically in the beta cells. It is also a peptide hormone similar to glucagon. It is cleared about 50% by the first pass. This is an important process because, again, it's going to mean that insulin is not around in the circulation very long. In fact, its half-life is only 3 to 8 minutes. Importantly, what we have produced at the same time as the peptide hormone insulin is something called C-peptide. Don't get this mixed up with C-reactive peptide. This is just C-peptide. C-peptide is then passed through this first pass system in a slower time frame. Therefore, it has a longer half-life, about 35 minutes. If you compare a 35-minute half-life versus a 3 to 8 minute half-life, you can see that C-peptide stays in the circulation longer. How is that useful for you clinically? How it's useful is that you can use C-peptide if you measure it in the blood as an index for how much insulin is being secreted. Because insulin's not going to be around long enough to really measure its concentrations. But if you measure C-peptide, you know it's produced in a 1-to-1 ratio. Therefore, if C-peptide goes up, insulin had to go up, and vice versa. You can see how this breakdown of this process works. If you see this polypeptide being formed, and there's a cleave that happens that forms C-peptide and insulin. So they'll be making this preformed pro-insulin peptide. You'll cleave a certain spot, leaving C-peptide and insulin as your two different secretory substrates.